go. Chapter 4B, lesson 5, multiplying and dividing. Today, things get a little wacky. So you're going to want to open those ears and listen, because you're going to need to be on high alert for something in particular when we're multiplying and dividing. And here's why. Notice that this is a true statement right here. 4 is less than 6. You agree? Yeah. Now, I'm going to multiply both sides by 2. Okay? So I'm going to multiply this side by 2. I don't like that crazy mouse. And I'm going to multiply this side by 2. That results in 8 is less than 12. Is this still a true statement when I multiply both sides by the same number?
Yes.
Yeah, this is still true. So I can continue to use that method of multiplying both sides by a positive number. Watch what happens when I multiply both sides by a negative 2. 4 is less than 6 is true. But when I multiply by negative 2, I get negative 8 is less than negative 12. If you look back here at this number line in the back, negative 8 is closer to 0 than negative 12. So is negative 8 smaller than negative 12? No, less is less. So the negative 12 is less. When I multiply by a negative, that statement is no longer true. And because of that, mathematically, mathematicians in your past have come up with a rule. When you multiply by a negative number, you must flip the inequality sign. This no longer can be a less than. It has to be a greater than. So when you have to use a negative number to multiply in order to solve, you have to switch the sign. Okay? That's pretty crazy. So that's what I was saying. You have to pay attention to that. Let's try division and see if that same thing is the problem for division. 4 is less than 6 is true. Let's divide both sides by a positive 2. We get 2 is less than 3. Is that still a true statement? Yes, it is. So it is totally okay to multiply or divide by a positive number. Let's try dividing by negative 2. Negative 2 is less than negative 3. This is a little tricky, so I like to look at my number line. Negative 2 is less than negative 3. Which one is more left? This one. So this one's less. Negative 3 is less. That is no longer a true statement. And so we have a rule. When you divide by a negative, you must what? Lift the inequality sign. This is the hardest part of this unit. Okay, so I would have to take this and flip it. Whenever you need to multiply or divide by a negative number to solve, your sign must flip. So let's try some and see what that looks like. We're going to solve algebraically and graph the solution, and today we're going to try some checks. Yeah, all right? Okay, so I see a variable and I see a symbol. I'm going to split and do the inverse. What's the inverse of multiply by 8? Divide by 8. Excuse me for a moment. Okay, so my 8 divides to give me 1x. I didn't divide by a negative, so I can just be normal and bring down my less than or equal to sign. And 40 divided by 8, Avery? You got it, less than or equal to 5. Looking back at my number line, I just want that little snippet of the number line where 5 is in the middle. So I'm going to write 4, 5, 6. 4, 5, 6. You can put a 7 there if you want. I skip lines so it's nice and neat. Okay? And I'm going to put a circle at 5. Am I going to shade in that circle?
Yes.
Yes, I am, because of this half and equal to sign here. That's a closed circle. And will I shade to the right or to the left? Yes, if this were an arrow, it would be pointing left. So all these numbers over here are less than 5. I'm going to check. I'm going to pick a number that falls over here and check it. A student probably 20 years ago gave me a great idea. If 0 works, I'm going to use 0. If it doesn't, I'm either going to use negative 100 or positive 100. Because they make it really obvious if you're right or wrong, and they're fun to use. Right? So, is 0 something that's going to fall over here? So I'm going to plug in 0. 8 times 0 is less than or equal to 40. Does that create a true statement? Yep. So I'm right. I have shaded the correct way. Did you get that? You can actually turn this stuff around. You shouldn't be facing it to the back like that. I don't know why that is. Why do they keep taking my pink away? I like pink. Okay, number 2. I see a variable and a symbol. I'm going to split and do the inverse. What's the inverse of multiply by negative 2? Divide by, ding, 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 ding. I said the magic word, divide by a negative. As soon as I hear those words, divide by a negative, I'm going to slide my symbol down and flip it so I don't forget. Because I said divide by a negative. Now I can continue. G is less than negative 5. Everybody catch that? That this symbol right here got flipped. And that's what we're going to graph on the number line, the new one, the flippy one. So look over there at my number line, negative 5 in the middle. I want that little piece of the number line. Negative 6, negative 5, negative 4, negative 3. Cameron, open or closed circle? Open circle at negative 5. And because my answer says less than, I'm going to shade less than over here. We're getting more and more negative. Now I have to check. When you check, you use the original. So I'm going to use negative 2 times something is greater than 10. The check does not have a flip in it. I'm checking the original problem before I did all my crazy flipping. What number would you like to pick? What number is going to fall over there, Carrie? Negative 100 is going to be way down there, isn't it? So let's plug it in here. What's negative 2 times negative 100? Luca? 200. Is 200 greater than 10? Yes. Yes. So when you use that number, negative 100, positive 100, it makes it very obvious if you're right or wrong. So it's tricky because you have to flip it here, but not over here.